In section 6.2, we're going to look at another application of integrals. And what we need to look at first is just a refresher on what the demand and supply function are. And then we're going to look at something called consumer surplus and producer surplus. So first of all, just a reminder of the demand function is really the amount of money that consumers are willing to pay for a certain number of units. So typically we represent the demand function as d of x. And what that would mean is d of x would be the price, or the y value is the price. So it's the price per unit that consumers are willing to pay when X units are made available. So then if we talk about the supply function, that's typically represented with S of X. So S of X would be the price, or the Y value, and X would be the number of units. So the supply function is the price that the producers are willing to produce and sell their a certain number of units for, so X units. So this is the price per unit producers are willing to produce or supply X units. And then the equilibrium point is the point where the supply and the demand are equal. So this is when sales are actually happening. So this is the point where the supply equals the demand. And this point you're going to see is going to be represented with X sub E comma P sub E, meaning the little e's just represent the equilibrium point. So it's the number of units and the price at the equilibrium point when the supply and the demand are equal. So visually, let's just take a look at what that looks like. So if we have a graph here, and let's say that this is our X and this is our Y, or P in this situation. So this would be price on the y-axis, this would be units on the x-axis. If we look at our demand function, so demand is going to be decreasing. So something like this. So this would be our demand function, d of x. And then our supply function would be increasing. And where these two intersect, or where they're equal, this is called the equilibrium point. So again, this is X sub E comma P sub E. So this right here would mean X number of units. And then this would be the price. So if we start talking about consumer versus producer surplus, consumer surplus is when the consumer benefits. So it's the difference between the amount that the consumer was willing to spend versus how much they actually spent. So it's the amount that they didn't have to spend that they were willing to spend. So let's write that down, and then we'll take a look at what that looks like visually so you can see kind of how this all ties into integrals. So this is going to be the difference between the total amount a consumer is willing to spend and the total amount actually spent. So if we look at this visually, so I'm going to kind of sketch that same picture, but the difference is I'm only going to look at the demand function here. I'm not going to look at the supply since we're talking about the consumer. So if I sketch in the demand function again, and remember that this is the price over here, this is P, this is the number of units, this is X. Again, let's just say that the equilibrium point was somewhere right here. So I'll say that this is X sub E and P sub E. So it's the price and the number of units for the supply and the demand to be equal. The consumer surplus is this area that's bounded between the demand function and the price at the equilibrium point. So this region represents that extra money that the consumers were willing to spend but didn't have to spend. So the consumer surplus is this region. So think about if you wanted to find this area, think back to section 6.1, the area between two functions. So we have d of x as one function and p sub e is just a horizontal line. So that's really, you can think of that as a horizontal function. You can think about it as y equals some number. So if you look at this, the d of x will always be greater in this region. So we're not going to actually have to test to see which function is greater. But d of x will always be greater. So what we'll do is we'll take d of x, we'll subtract off this horizontal function, p sub e, and then we'll integrate between 0, because this is 0, to whatever that number of units at that equilibrium point. So that's where, if you look down below, where this formula comes from. So it says that the consumer surplus is equal to the integral from 0 to that x value at the equilibrium point of the greater function, which is the demand function, minus the constant. So that's where this comes from. So let's go ahead and look at an example so you can kind of see what this means and what this looks like in terms of calculating. So if we read this example, it talks about the demand for a particular item is given by this function d of x. And we want to find the consumer surplus if the equilibrium price of a unit is $250. So first of all, I read that, and that represents P of E. That's the equilibrium price. So P of E is equal to 250. Now, if you think about that formula, the consumer surplus formula from the previous page, so C of or CS, consumer surplus, is equal to the integral from 0 to x of d of x minus p sub e. Again, I'm just taking this formula right from the previous page. And if you look at what we have, well, we have d of x. So I have that. I have p of e. And now what I need to know that I don't have is x sub e. In order for me to actually plug in and integrate, the first thing I need to do is find x of e, or x sub e. So what I'm going to do is my first step here before we can plug into our formula is going to be to find x sub e. And the way to do that is, well, x sub e represents the x value, or the number of units at the equilibrium point. So when the price is equal to 250. So basically what we're going to do is we're going to take our demand function. So d of x equals 1450 minus 3x squared. And we're going to replace d of x with 250, because this really means d of x is equal to 250. So 250 is equal to 1450. So we're just going to solve this for x. So I'm going to go ahead and get this equal to 0 because I see the x squared, which means I'm going to need to factor or at least get it equal to 0 on the one side before we figure out what we're going to do. And then from there, I want to try to get a 1 in front of that x squared. So let's just go ahead and divide everything by 3. So we get 0 equals 400 minus x squared. And then at this stage, you have options. You can either do difference of perfect squares factoring, since you have 2 perfect squares. Or what we can end up doing here is just bringing the x squared over, or 400 over, whatever way, and solving for x. So what I'm going to do is bring that x squared over so it's positive. And then from here to solve, I'm just going to square root both sides. So I get x equals plus or minus 20. And then I'm going to reject the negative here because we don't want negative units. So it's just going to be x sub e is going to be 20 units. So that means the x value at the equilibrium point would have to be 20 units. So when the price is $2.50, the number of units is 20. That's what it's saying. So now that I have all three things, meaning I have the x sub e, I know the p, and I know the function d of x, well, now I can plug into my formula. So I'm going to go ahead and write down my formula for the consumer surplus. So it's always going to be d of x minus p sub e, because d of x will always be greater. And then and now I can plug in. So 0 to 20 are going to be my bounds. D of x, I got to go back up to the problem here. So that's going to be 1450 minus 3x squared. And then minus 250. And then from here, we just do our integral. So this just turns into an integral problem. So I'm going to just combine like terms before I start integrating. So I get 1200 when I subtract the 1450 minus 250 minus 3x squared. And now at this stage, we can start integrating. So I have 1200x minus 3x to the third over 3. And then we're going to just keep our bounds at the end. And before I plug in, though, if I can simplify this, which I can just divide the 3, so that 3 divided by 3 is just 1, so it makes it a little bit easier. So now I can go ahead and plug in. So I have 1200 times 20 minus 20 to the third. So there's plugging in 20, so I want to get that entire number. And then I'm going to plug in 0, which you're going to see a lot with these, that the second part of this will often go to 0, or when you're plugging in 0, it'll often, this whole thing here just ends up becoming 0. Not always, so just be careful, but a lot of times that will happen, just because when you're plugging in 0, the numbers multiply out and end up being 0. So then when I get this value here, the first value, I end up with $16,000. So that represents the consumer surplus. So that represents the amount, the difference between the total amount a consumer was willing to spend and the amount that they actually spent. So that $16,000 represents the amount that the consumer would have been willing to spend more, $16,000 more, than they actually had to spend. So that's kind of think of it as their savings.